Welcome to this class of acoustics through slideshow. Today's chapter is acoustics. We will be passing through different slides in acoustics. In this class, we will study what is reverberation, what is reverberation time, what is absorption coefficient, how this absorption coefficient is determined, what is meant by absorption, and then we go on to Sabine's formula and then some fundamentals in building acoustics. These are the concepts we are going to study in today's class. First, let us study reverberation. To study reverberation, let us consider a closed room. Let the rectangle represent a closed room. S is the source where the sound is produced and O is the observer. The sound produced from the source, it reaches the observer along different paths. The direct path is SO. It can also reach the observer along the path SAO. Here, the sound undergoes one reflection at A. It may pass to O after two reflections by traveling along the path SBCO. Along the path SBCO, it undergoes two reflections. Along the path SDEFO, it undergoes three reflections. Like this, it undergoes several reflections and reaches the observer. The sound that is received after first reflection, it will be a little later after the observer receives the direct sound. The sound received after two reflections, that is along the path SBCO, it reaches with some more time difference. And the sound by three reflections, it takes some more time. So the sound will be received continuously, one after the other. Direct sound SO, next SAO, next SBCO, next SDEFO. Along these paths, the sound will be received at regular intervals. For studying reverberation, we use a concept known as reverberation time. We define reverberation time to study the effect of reverberation. The sound produced, initially the intensity rises. So if you draw a graph between time and intensity, that intensity initially rises to a maximum A and then it decays slowly from A to C. We define reverberation time as, to understand reverberation time, first we have to understand a concept known as threshold of audibility. It is 10 to the power of minus 12 watts per meter square. So an energy of 10 to the power of minus 12 watts, which is incident on 1 square meter area, is known as intensity. This is the lowest intensities of sound that is recognized by a normal ear. By a normal ear, the sound received, it is recognized, is the lowest sound recognized is known as threshold of audibility. Let us indicate with X. Then the intensity of sound received will be continuously decreasing. So starting from an initial level of 10 to the power of 6 times to the threshold of audibility, starting from an initial value of 10 to the power of 6 times threshold of audibility. That is, if threshold of audibility is x, then the initial intensity should be 10 to the power of 6x, or it is 10 to the power of minus 6 watts per meter square. That should be the initial intensity. From that intensity, the sound slowly decreases and comes to the threshold of audibility 10 to the power of minus 12 watts per meter square. So A is this 10 to the power of 6 times threshold of audibility. From that intensity, C is threshold of audibility. So the intensity, the time taken for the intensity to fall from A to C, that is capital T. In the figure it is BC, time is BC, that is BC is indicated with time, the threshold of audibility capital T. So the time of fall from A to C is known as threshold of audibility. For studying reverberation, we use a concept known as reverberation time. We define reverberation time to study the effect of reverberation. Factors that determine the reverberation time. Generally, we calculate reverberation time in the case of an auditorium or a theatre. So whenever we consider such a structure, inside that the reverberation time depends on the absorbing surface area. The surface area. Absorbing material nature. Sometimes we spread carpets, the nature of the carpet, and then surfaces that are present. If the surfaces are hard surfaces, then most reflection takes place. The reflection will be higher if hard surfaces are present. Soft surfaces absorb sound. So the reverberation time depends on the nature of the surfaces. Moreover, it depends on the number of audience present. Audience will also be counted as absorbing bodies, absorbing surfaces. So it depends on the absorbing surface area and the nature of the material present in a room. On these factors, the absorbing, the time, reverberation time depends. What is the effect of reverberation time? If reverberation time is very, very small, sometimes less sounds, less intense sounds will be inaudible. And if the reverberation time is large, the clarity will be lost. If T is more, the clarity is lost. If T is less, whispers, small sounds like whispers, will be inaudible. You cannot hear whispers when T is less. When T is large, the reverberation time is large. The reflected sound will not subside in a short duration. So it gets mixed with the newly produced sound and the clarity of the dialogue will be lost. The clarity will be lost if the time is more, and the low voices, low intense voice like whispers will be inaudible if T is very, very less. The nature of the surface is measured with a quantity known as absorption coefficient. It is sound absorbing capacity. Generally, we indicate this by a letter small a. When sound is incident on a window, if the window is open, the entire sound will pass through the window. If the window is closed, a part of the sound will be reflected. Reflection occurs when the window is closed and the energy will pass through, the entire sound will pass through the window if it is open. Then we say the open window absorbs the entire energy, whereas closed window absorbs a part of the energy. Let us suppose EW is the incident energy that entire energy is incident. The entire energy that is incident will be absorbed by a open window. Let EA be the amount of the energy absorbed by a closed window. EA is the amount of energy absorbed by the closed window. Then the ratio EA by EW is called as absorption coefficient. The ratio EA by EW is known as absorption coefficient. This will be indicated by small a. So it is the ratio of the energy absorbed to the energy incident. This ratio is called as absorption coefficient. Let us recollect some of the absorbing surfaces. Let us recollect some of the absorbers, sound absorbers. Examples of absorbers are thick curtains. Generally, thick curtains will be laid near the windows, doors and windows in a theatre. They are very good absorbers. Mats will be spread on the floor. Carpets will be spread on the floor. They are also good absorbers of sound energy. Wood is also an absorber. Cardboard is also an absorber. So these are the materials that absorb the sound energy. Thick curtains, mats, carpets, wood, cardboards, etc. are the materials that absorb the sound energy. Though different substances absorb sound, but the degree of absorption will be different. So that will be measured with absorption coefficient. Now let us pass on to the methods that are adopted in determining the absorption coefficient. What methods can we use for finding this absorption coefficient A? It is determined, we study two methods. The determination of absorption coefficient is by two methods. One is stationary wave method, the other one is reverberation time method. Here we study two of the methods that are used for finding the absorption coefficient. One is stationary wave method and the other one is reverberation time method. Let us discuss these two methods in detail. Determination of absorption coefficient by stationary wave method. Determination of absorption coefficient by stationary wave method. Consider a wall and a wave is incident on this surface. Then it gets reflected. The reflected wave falls on the incident wave and stationary waves are formed. Stationary waves are formed. Inside the stationary waves we notice nodes and antinodes. Let us take a device which converts sound energy into electrical energy. Let us move this device in the stationary wave. When it comes to the position of antinode, a large current will be noticed. When it comes to the position of nodes, a small current will be noticed. Let us indicate the currents as I1 and I2. Let I1 be the current at antinode and I2 the current at node. Then the absorption coefficient is given by the relation. The absorption coefficient is given by the relation A is equal to 4I1 I2 divided by 4I1 I2 divided by I1 plus I2 whole square. I1 plus I2 whole square. Using this relation, we measure the absorption coefficient. Now let us pass on to the study of the absorption coefficient by reverberation time method. Determination of absorption coefficient by reverberation time method. Let us take a chamber. In this chamber the reverberation time is say T1 in the empty chamber. The reverberation time in the empty chamber is say T1. The material whose absorption coefficient is required is pasted on the walls of this chamber. The material whose absorption coefficient is required is pasted on the surface of this chamber. Let V be the volume of this chamber and S the total surface area of the chamber. Let us suppose A0 is the absorption coefficient of the walls of this chamber. The absorption coefficient of the walls of the chamber is A0. The volume of the chamber is V. The surface area of the chamber is say S. Then, after pasting the material, if the reverberation time is determined, let us suppose that time is T2. The reverberation time with the material pasted on the walls of this chamber is say T2. Then the absorption coefficient of the material which is pasted is A and is given by A is equal to 0.17 V by S, 0.17 V by S into 1 by T2 minus 1 by T1, 1 by T2 minus 1 by T1 plus A0. This is the relation that is used for determining the absorption coefficient by reverberation time method. Now let us study Sabine's formula. This is not a theoretically derived formula. This is an empirical relation used by Sabine. If A is absorption coefficient and S is the surface area, then AS is called absorption of that surface. If there is a surface of area S whose absorption coefficient is A, then the product AS is termed as absorption of that surface. If there is a room with different surface areas and different coefficients, then the total absorption of that room is given by A is equal to sigma AI SI. Let the volume of the room is say V. Total absorption is A, which is equal to sigma AI SI, and the total volume of the room is V. Then it is found by Sabine that the reverberation time varies directly as the volume. The reverberation time is directly proportional to the volume and inversely proportional to the absorption of the room, total absorption. So T is proportional to V, T is proportional to 1 by A, or T is proportional to V by A. The proportionality constant is obtained as 0.17 in SI units. Hence, the relation for reverberation time by Sabine is given as T is equal to 0.17 V, T is equal to 0.17 V divided by sigma AISI, sigma fundamentals of building acoustics. Here we take certain points that are required, that should be considered when some concert halls are constructed. We have to provide adequate sound to the audience. So, to provide adequate sound, we see that the speakers are arranged a little above the seat in the hall. every seat will be at certain distance from the speaker. The reverberation time of that hall will be set for an optimum value. The reverberation time will be set for an optimum value. To prevent extraneous sounds, we hang thick curtains. Thick curtains are hung to prevent extraneous sounds entering the room. Sometimes we notice echoes effect, that is reflected sound effect. To eliminate this echo effect, the speakers should be so positioned they do not directly face a wall. Echoes are eliminated by positioning the speakers such that they do not face the wall. If the surface behind the speaker is spherical or concave, then focusing of sound takes place. That is why the surface behind the speaker will be paraboidal in shape so that focusing is eliminated. Because of paraboidal surface, the intensity of sound will be sent uniformly into the room. If the staircase is there inside a concert hall, the sound reflected from the steps of the staircase produces a musical note. Such an effect is known as echelon. To prevent this effect, echelon effect, the staircase will be covered with mats. The staircase will be covered with mats to prevent echelon effect. Like this, we have to take certain precautions while constructing. Let me summarize what we have learnt so far. When sound is produced in a closed room, multiple reflections takes place and we will be receiving continuously the sound even after the source is cut off, until the reflected sound intensity falls to the minimum noticeable detectable sound level, that is threshold of audibility. Until then it will be noticed. This is reverberation. We measure this reverberation with a time known as reverberation time, which is starting from an initial level of 10 to the power of 6 times the threshold of audibility to the threshold of audibility. This time changes with the absorbing surfaces and the nature of absorbing materials inside the room. It depends on the absorbing surfaces and the nature of the absorbing surfaces. So to study this nature, we use another constant known as absorption coefficient. It is defined as the amount of intensity absorbed, sound intensity absorbed, to the amount of sound intensity incident on the surface. Like this we define a absorption coefficient. That absorption coefficient will be determined by two methods. One is stationary wave method, another one is reverberation time method. Using these methods we determine the absorption coefficient, and the absorption coefficient into surface area is defined as absorption. The sum of the absorptions of all the surfaces is sigma AS. This is total absorption. Then if V is the volume of the room, then the reverberation time is given by Seben's formula. T is equal to 0.17 V divided by sigma AISI. This is the formula given by Seben. Then we will pass on to building acoustics, in which we study certain conditions required for a good auditorium.